Okay, so we'll start immediately. So this is a new method, that is Runge Kutta method of fourth order. It's simple. We say it as RK method of fourth order, and it is important, very important for final exam also. So you should be very careful with this method, and it will help you to get score good marks in the examination. And I would like to inform you that this is the last method in this unit. So we're going to finish today this unit with Runge Kutta method of fourth order. So just write down this, students. So what it says in this, we have, by using ordinary differential equations, we are going to solve this order fourth method, that is dy by dx is equal to f of xy and y of x naught is equal to 0. So one by one you can see we're going to simplify. First we'll find y of x1, then again we have the formula yn plus 1 is equal to yn plus 1 upon 6 k1 plus 2 k2 plus 2 k3 plus k4, right? So like this, friends, here also we are going to have the formula. First you try to understanding how we are going to, what this method is going to tell you. So just brief introduction. Consider the initial value problem. Dy by dx is equal to f of x comma y. Yes, please student mute yourself. Okay. Okay, consider the initial value problem. Dy by dx. Okay. Consider the initial value problem. Dy by dx is equal to f of x comma y and y of x naught is equal to y naught. We need to find y of x naught plus h here. Yes, here the change is we have to find y of x naught plus h, where h is the step size. So as I have discussed already, h is nothing but the interval. It is the step size or step length, we say, students. But Runge Kutta method says that h we are going to take it as the step size. So here we'll follow up with step size. Step size is nothing but again it is an interval. So remember this. So we have to first compute k1, k2, k3, k4, where k1 is equal to, yes, students, start repeating the formula, start remembering the formula. K1 is equal to h f of xn yn. K2 is equal to h f of xn plus h upon 2 comma yn plus k1 upon 2. So k1 already in the previous approximations we get, we'll substitute here. Okay, we'll go with the k3. K3 is equal to h f of xn plus h upon 2 comma yn plus k2 upon 2. So k2 is from again previous approximation. Next we'll go with the k4. K4 is equal to h f of xn plus h comma yn plus k3. So the required formula, required equation, friends, write this formula again. So the required equation we get is equal to yn plus 1/6 plus 2 k2 plus 2 k3 plus k4. Yes, any doubt?
Why is it breaking?
Yes.
Voice is breaking, sir.
So you are not audible clearly.
The voice is breaking, sir.
Yes. Wait, we'll just check the internet. It is available. Some internet problem is there. Okay, fine. Now is it audible? Yes, students?
Yes.
Fine, thank you. Okay, we'll start the class now. Okay, so what I was saying is the required equation yn plus 1 is equal to yn plus 1/6 k1 plus 2 k2 plus 2 k3 plus k4. So this is very important, student. You have to remember for every example when they ask you RK method of fourth order or Runge Kutta method of fourth order. So we just see with the example. Yes.
So K4, it's so for that K4 we have to don't divide that h upon 2.
Yes, it is not there. H upon 2 is not there. You have to remember like this formula, students. Very important and very carefully you have seen for K4 is equal to H f of xn plus h. It is not h divided by 2 here. K4 will change. Remember, K4 is different from K1, K2, K3. Is it clear? So this is how we have to remember.
So I like that.
See, it is there in the derivation. Actually, derivation was there, but in your syllabus, derivation is not there. So I'm just giving directly the formula only. So when we consider the initial approximation, at the end, we are not going to divide this interval because it said we have already attended the approximations. We have got the already the approximation, so no need of again dividing the interval. So we get the exact approximation or accurate approximation in K4 itself. So when we add in Kn yn plus 1, the required equation, when we add, it is going to adjust with the accurate values. We will go immediately for solving the example.
So you are
The
not audible.
example. Yes.
So you are not audible.
Sir, not audible, sir.
Sir, you are not audible.
Is it?
No, sir.
I think some everyone conducting classes online, so everyone is using internet. So I think will get finished early. Fine. So we'll continue the example. So please write down the example. Runge Kutta method to find an approximate value of y. That is 0.2 that is equal to y square. Given that y is equal to 1, where x is equal to 0 and h is equal to 0.
Sir, you are not audible.
Your voice is breaking, sir. It's not audible.
Your voice is breaking. Your voice is breaking, sir.
Everything is given. Understand this? This is the first example. So what is given, just we'll go through once again. Okay. So we take as h is equal to 0.1. We carry out in 2 steps. Tell me why. Anyone? Please tell me why we carry out in 2 steps. Anyone? Anyone can unmute and tell me why we carry out in 2 steps. I will tell you very simple. Because here x is equal to 0.2 we have, correct? Yes or no? So when we have h is equal to 0.2, 0.1 will be the first initially, then we go for the second step 0.2. So therefore we have 2 steps. Is it clear? Shall I repeat once again? See, why we carry out this in 2 steps, students? It is because initial when we start the approximation, can anyone tell me what will be the initial approximation? Yes, anyone please? Can you tell me what is the initial approximation?
0.
Yes, very good. X is 0. Excellent. Therefore, one we have to calculate for x is equal by taking x is equal to 0, and another one we have to take x is equal to 0.1 because the step size is 0.1. Very good. So I think some have understanding how to identify the initial value problem. Therefore, x naught we are going to take this as 0 and y naught is equal to 1. So f of x y is what we have, students. It is x plus y square. So remember this function will change. Remember it is going to be initially 0, 0, 1, 1, 2, 2. It is going to change the function. Next, immediately we'll find the form. First we'll write the formula from Runge Kutta fourth order method. K1 is equal to h f of x naught comma y naught. Here please substitute the values now. So by considering what is given here, h is equal to 0.1. F of x naught y naught will become, by using the function y square, what will become here? Function is going to be x naught y naught square. Right? So just substitute 0.1. This is 0 and 1. X naught is 0, y naught is 1. So the function is going to become 0 square. Because values is going to become x and y. X is 0, y is 1. So substitute the values for k1. Answer you are going to get here is 0.100. That is our approximation k1. Then further we'll continue this for k2, as I have told you to remember the formula, students. So it is k2 is equal to h f of x naught plus h upon 2 comma y naught plus k1 upon 2. So remember this formula, students. Now practice this formula now only, today only, without saying you try to solve this example at home also. So this is going to become h is 0.1, substitute 0.1. Then we have f of 0.05. Yes, if you substitute x naught plus h upon 2, I'll just simplify this. X naught, what we have, 0, so no need of that. What we have, h is 0.1. 0.1 divided by 2. Yes, just think. 0.1 divided by 2 is 0. Yes, very good, excellent.
0.05.
So you are understanding. Yes, it is 0.05. So directly I am writing here. Can you tell me what is y naught plus k1 upon 2? Y naught is 1. Okay, k1 0.1. So 1 plus 0.1 divided by 2 it is. So when you simplify this, we get this as 3. Yes, can anyone tell me? It is 1.1. Yes, very good, student. So like this you have to simplify. Now substitute in the given function. So x here 0.05 and y we get 1.1. So when you simplify this function, students, it is going to become, so please write down fast, it is 0.1152. So this is how we are finding the k2. So by this you are going to find for the next one k3. So immediately write down, students, k3 formula. K3 is equal to h f of x naught plus h upon 2 comma y naught plus k2 upon 2. Yes, this is going to become, now here h is 0.1. Yes, and then now you can find x naught plus h upon 2. So x naught plus h upon 2 again remains. What will be x naught plus h upon 2? So here I have taken 0.1. Yes.
Excuse me, sir.
Then yes,
Sir, can you explain K2 once again?
k2. Okay, wait. Where I was? Okay. K2 is equal to h f of x naught plus h upon 2 comma y naught plus k1 upon 2 we get. Correct. So h is nothing but 0.1 we get, and f of x naught plus h upon 2. X naught we have taken here 0 plus h upon 2. H upon 2, what we get here? H upon 2 is 0.1 upon 2. Upon 2 will become 0.05. Comma y naught plus k1 upon 2. Y naught, what we have, student, 1. K1, what we have, k1 0.1. So 0.1 upon 2. When you simplify this, you're going to get
Sir,
0.1.
the second value is
If you simplify this,
1.05 though.
yes.
Sir, instead of
Oh,
1.1, it is 1.05.
1.0. Okay, substitute 1.0. Yes, you are right. I cannot change this. Just you try to substitute and tell me the answer what we get.
Sir, your voice is not clear.
So your voice is breaking, sir.
Try to substitute this value now.
Sir, it is correct. 0.1152.
Huh. There some things. Okay. So the value you get 0.1152. So there is no option. There is no problem. Answer you get to get this as 0.1152. So write the formula, substitute values. So we are going to get answer will not change. It is 0.1. Some values I have just misplaced. In fast, I have just misplaced the value. Sorry for that. But answer you are going to get here. Then I think I have just misplaced here also. So K4 is equal to what we get actually it is. Remember this h f of x naught plus h. Okay. Don't change this x naught plus h, comma y naught plus k3. Y naught plus k3. So you can just simplify directly, students. It is 0.1 f of 0.1 comma 1.1168. So when you substitute the values, it is going to become 0.1 bracket 0.1 plus 1.1168 square, because x plus y square it is. So when you substitute, this is going to become 0.1347. So by mistake, sorry for that, I have just misplaced one value here. Try to remember that it is 0.05. There also it is 1.05. Just, but answer you will get same. That is not an issue. So we'll continue like this. Therefore, at the end, what is the formula we get here, student? Y of x naught plus h is equal to y naught plus 1 upon 6 k1 plus 2k2 plus 2k3 plus k4, students. So remember this formula and practice. Yes. Now substitute all the values in this. Substitute all the values. So we get y naught is nothing but 1 plus 1 upon 6 remains as it is. K1 is 0.1. Yes. Plus 2. K2 is 0.1152 plus 2. K3 is 0.1168. Substitute the values plus K4 we get 0.1347. I think you have, everybody have understood what is arcane fourth order method. So substitute values. Therefore we get y of x naught is 0. So I'll put 0. H is nothing but 0.1. Substitute 0.1. Therefore y of 0 plus 0.1 is equal to y of 0.1 we get, and then is going to become, if we substitute directly, the value you are going to get here is 1.1165. So we get y of 0.1 is equal to 1.1165. Okay, student, we'll go for the step 2. Now you'll understand clearly. In step 2, x1 is equal to x naught plus h. As I have told you, Arche method initial value, the x value you have to take here, x1 is equal to x naught plus h in the step 2. And also remember, student, x naught already it is given. I'm going to take here 0 and h 0.1. Therefore, in step 2, x1 we are going to change x naught, we are going to become x1. Remember this, I'm repeating again and again. X naught is going to become here x1. x1 is equal to x naught plus h is equal to 0 plus 0.1. So x1 is going to become 0.1. Then y1, student, what can you tell me what will be y1? Previous step, you can see y1 is equal to 1.1165. You have to take this previous approximation, y1 is equal to 1.1165, and remember h is equal to 0.1. Okay, immediately go for all the formulas of Runge Kutta fourth order method, that is k1 is equal to h f of x1 comma y1. Values now, students, h is 0.1, f of x1 is 0.1 and y1 is 1.1165. So substitute values, student, is equal to 0.1 plus y square, student. Remember, x is 0.1 square is 1.1165 square. You calculate this in answer it is 0.13. Yes. K1 we get 0.1347. Let me go for the next method, very important, that is K2 is equal to H f of x1 plus h upon 2 comma y1 plus k1 upon 2 is equal to. Now substitute the value, students. It is 0.1 f of, I can calculate this, x1 is 0.1 plus h upon 2, 0.1 upon 2. So it is going to become 0.15, students. Here also y1 plus k1 upon 2. Y1 what we have, 1. We are going to get 1.8.
Sir, you are not audible. Sir, you are not audible. Sir, please repeat.
Beta K2, I think internet problem is there, so we'll just go slowly. K2 is equal to H f of x1 plus h upon 2 we have, comma y1 plus k1 upon 2 we get, this is equal to, h is nothing but 0.1. Substitute that. F of x1 what we have, students, here 0.1 plus h is nothing but 0.1, so 0.1 plus 0.1 divided by 2, so we are going to get this as f of 0.15. Next value how we get, y1 plus k1 upon 2. Y1 what we have, 1.1165 we have, plus k1 is nothing but 0.1347. 0.147 divided by 2. So the answer will be 1.88. Here x is 1.5 and y is 1.838. So substitute in the value, we get it is
So
nothing
your
but
voice
0.
is breaking a lot.
Voice is getting back.
Yes, sir. Why? Yes, sir.
Because I think some network is slow, but we are getting here net clearly. There is no problem with net, I think. Okay. Now it is audible, students? Yes, it is audible, students?
No, sir.
And just go slowly now. I think all the classes are going on, therefore the net is slow a little bit. So already you have understood now how to simplify. Just substitute the values and try to get the answer now. In step 2, repeat the same steps from step 1. That will be easy. Repeat from step 1. Same formulas is I am going to use. Only values will change to your students. So repeat whatever we have done in step 1. Repeat for step 2. So just substitute h as 0.1 and then, yes, student, am I audible?
Yes, sir.
Okay, thank you. So we'll start now. So substitute is 0.15 plus y is square. If you simplify, you can get equal to 0.1551. Like this we get here. Now we'll go for K3 values. So first you please write down again formula. K3 is equal to f of x1 plus h upon 2 comma y1 plus k2 upon 2. H upon 2. X1 what we have here, 0.1 plus h is 0. When you substitute, we get here 0.15. Similarly, plus 4.2. Y1 what we have here, student? It is 1.165. K2 is 0.1551 divided by 2. So 1.1165 plus 0.1151 divided by 2, we get the value 1.194. So f of 0.15 comma 0.194. So like this one calculate orally. This is become runs. So this is 0.1 as it is. X is 0.1. So minus 1.11.194 square. So when you simplify and substitute the values.
Sir, you're not audible.
Your voice is breaking again.
It is, yes, K3 value you are going to get here is 0.1576. So it is visible, you can just write it down, so there is no problem. Only audio is little
Excuse me,
bit.
sir.
Yes, tell me.
Sir, how did you get x1 0.15?
X1 is not 1.15 here, it is
No,
x1
sir.
plus h upon 2. That is what it is, x1 plus h upon 2. X1 is 0.1 plus h is nothing but 0.1. So 0.1 divided by 2, 0.05 plus x1, that is 0.1. So 0.1 plus 0.05.
Okay, sir. Thank you.
Sir, not audible.
Okay. 1.194.
Not audible.
194 is 1 plus K2 upon 2. What is Y1? Y1 is nothing but 1165. 1165. So divided by 2. So it is going to become 1.194 student. So when you square it, you are going to get 0.1576. Some internet issue is there. Visible means you write it down. That is not a problem. Okay, so immediately we'll go for K4. K4 is equal to H. The formula f of x1 plus h, y1 plus k3. K3 is from the previous example. H is 0.1, substitute 0.1, and then f of 0.2, 1.1576. Substitute the value, students. So we get here is equal to 0.1. X is 0.2, so substitute x plus y is 1.1576 square. So we substitute.
So even the video is not playing.
It is playing. Okay. Is it visible, students? I think now is it visible?
Yes, sir.
Okay, thank you. So it is audible and visible also. Fine. So some are getting not clear. Why? Because of the some internet problem, I think. But you can go through your video afterwards. I will upload it. You can just go through. Yes, please. So please we'll continue this K4. So K4 is equal to 0.1 in the bracket 0.2 plus 1.1576 square. So when you calculate this, students, so we get K4 is equal to 0.1. So next, so all the values you got K1, K2, K3, K4. After calculating all these four values, remember, students, you are going to substitute in the next value, that is y of x1 plus h. So please write down the formula once again. I will repeat. Runge Kutta method formula: y of x1 plus h is equal to y1 plus 1 upon 6 k1 plus 2k2 plus 2k3 plus k4. So substitute all the values. Y1 is nothing but 1.1165 students plus 1 upon 6 in the bracket k1 is going to become 0.1347 plus 2 into k2 is 0.1551. Substitute the values plus 2 into k3 is 0.1576. Students, substitute values plus k4. K4 value we have calculated it as 0.1823. Students, substitute the values. All the values when you substitute, we get y of 0.2, which is equal to 1.2736. So we get the answer. It is y of 0.2 is equal to 1.2736 students. So this is how
Excuse me,
it
sir.
is very simple. Yes.
Sir, K4 we are getting 0.177.
K4 you are getting 1 point.
No, sir, I got the same value as you.
Yes, sir. Got it.
The same. Just use a simple calculator and try to get the answer. That is not much difference. 1-2 values change, okay, but not completely answer. 0.1 something you will get. 0.18 is enough. 2-3 that will change. That is not a big problem. Okay, fine. So please just try to use correctly. Values are correctly, you definitely will get the terms correctly. So I will just repeat this once again, okay, so that it will be helpful you to understand, because it is very important method. It is Runge Kutta method of fourth order. Just consider the initial value problem. dy by dx is equal to f of x comma y of x naught is equal to y naught. That is what it is given. So we need to find y of x naught plus h. Yes, that is what we have done, where x is the step size. Remember. So we have to first compute k1 plus k2, k3 and k4. So what the formula given for k1 is equal to h f of x and y. Initially this n is going to become 0. In the second approximation n is going to be 1. That is clear. Okay. So n initially will become 0. So x and y is going to become x naught y naught. Remember this, students. So it is in k2 is equal to h.
Your voice is breaking.
Yes, any doubt? Repeat the question. Any doubt? Okay. I think some voice is breaking. Okay, we'll continue. K2 is equal to h f of xn plus h upon 2, comma yn plus k1 upon 2. And K3 is equal to h f of xn plus h upon 2, comma yn plus k2 upon 2. And K4 is equal to h f of xn plus h. Here we don't have h upon 2. Remember this. Yes, very important. I will repeat here once again. K4 we don't have h upon 2. You may rewrite it correctly. Yn plus K3. Here also K3. There is no divided by 2. Remember K4 we don't have any h upon 2. K3 upon 2. It is h and K3 itself. I will repeat once again. K4 is different formula. K4 is equal to h f of xn plus h, comma yn plus K3. Yes. So the required condition what we get here is yn plus 1 is equal to yn plus 1 upon 6 k1 plus 2k2 plus 2k3 plus k4. Remember here, students, as approximation goes on increasing, like step 1, step 2, step 3, the approximation increases. Therefore, n value also changes from this formula. N will become 0, 1, 2 and so on. So we'll go immediately for the example, very important example. So this is what we have the example. What is given h 0.1. So this is carried out in steps, already you know. Remember, initially x will become 0 and then we'll go this one. So here we get all the, if we calculate the properly, we're going to get 0.1. K2, substituting the values, get 2. K3, if you substitute values properly and calculate using the function, you're going to get 0.1168. K4 value will become 0.1347. After finding K1, K2, K3, just substitute in the Runge Kutta fourth order formula, that is y of x naught plus h is equal to y naught plus 1 upon 6 in the bracket K1 plus 2K2 plus 2K3 plus K4, which is equal to 1 plus 1 upon 6, 0.1 plus 2, 0.1152 plus 2.01168 plus 0.1347. When you simplify, you are going to get the answer for y of 0.1 is equal to 1.1165. Similarly, repeat the same for step 2. No change, only values will change. Formula remains as it is. only the given value I'm going to write like this: x1 is equal to x0 plus h. So you may think that what is this x1? X1 is h0 plus h. X0 is 0 and h is 0.1. So x1 will become 0.1. And y1 is the previous approximation, that is 1.1165. So by using these values, calculate k1, we get 0.1347. K2 value we get here 0.1551. K3 value we get 0.1576. K4 value you get 0.1823. Taking all these values, K1, K2, K3 values, substitute in Runge Kutta formula, fourth order method of formula, that is y of x1 plus h is equal to y1 plus 1 upon 6 in the bracket k1 plus 2k2 plus 2k3 plus k4. When you substitute all the values correctly, you have to get y of 0.2 is equal to 1.2736. So this is how we have to calculate this, students. Very, very important. Yes. Now immediately next example. Next example. So I will show you